Welcome dear students, welcome to a new session. So this is our second classroom, isn't it? So what do you feel about the previous class? How was it? Do you remember the things that we learned in the previous session? Okay, anyway, welcome you all once again. This is the language of physics and myself, Kiran Freddy. So let me check whether you remember the things that we learned in the previous class. So what was that? First thing, it was about matter and its properties and what matter composed of and all those things. And we get to know that matter is composed of very tiny particles called as molecules, and the properties of molecules, like they are very tiny, there is spacing in between them. What is it called? Intermolecular space, and there is some kind of attraction in between them, that is called as the intermolecular force of attraction. Okay, and they are always in motion and hence they may have kinetic energy. And these are the things that we learned in the previous class. I hope you studied all these things very well. Yeah, fine, good. I hope so. Anyway, I told you to try one experiment at your home. I hope you have done that experiment. And what's your experience about that? How was it? Anyway, I know that many of you might not try it at your home. Okay, anyway, we are going to try that experiment in the first session. We are going to try that experiment now itself, okay, so that you can understand the things very well. And before doing the experiment, let me say something. We are trying to understand some basic things from this small experiment. That is, there is space in between the molecules. So from this experiment, what we are going to do is that we are going to have some water and we will check the level of the water. And after that, we will put some salt in it and stir it well. After that, we will check the level of water again. Usually in our basic concept, we may feel like the level of water will rise. But we will get to know that after stirring, when this salt is completely dissolved, then the level of water will remain unchanged. So what will be the reason behind that? Yeah, that's what we are going to understand from this experiment. So let's try it out. Then dear students, we are going to try that experiment, and for that we are having a beaker. Okay, then in this beaker we can have some water in it, and in this beaker we can understand the level of water clearly because it is marked over here. We are going to have around 150 ml of water. Okay, you can see the level of water in it. Yeah, it is exactly 150 ml in it. Okay, so now you can understand what we are going to do. We are going to put some sugar in it, and after that we stir it well. Then we will check the level again. Okay. So dear students, we can see that here the level of water is only 150 ml, right? That means the matter contained in this vessel is liquid, that is water, and it occupies the space that is shown in this picture like this. Then we know that if we place any other matter in this container, it also needs space to occupy, and usually then we know that the level of water may rise. You can understand that from this simple experiment. This is a glass block. I am going to insert this glass block into this vessel. Then the thing is very simple. You can understand the level of water will rise because this glass is also another matter and it needs space to occupy. When it is getting the sufficient space, as the level of water will simply rise. Yeah, now it is around above 200 ml, isn't it? So what is the reason? Yeah, there is space for this glass to occupy, so it will usually rise. Okay, now the things will be different if we put some salt in it, because that when the salt get dissolved in the water, then the water molecules doesn't need much more space because already space in between the molecules. Okay, so that's what we are going to see by this experiment. Okay, so let's do that. Then I'm going to do that. So in this beaker, I'm going to put some sugar in it. You can see this sugar. Then you need to understand what is going to happen. Okay, when I put this sugar into this water, this sugar molecules, sugar will get dissolved in it, and it will change into the molecular level, and all those molecules may get the space in between the molecules of this water. So there is no need of much more space, and as a result the level of water may remain same. Okay, so we have to do it and understand. So I am going to pour this sugar into this beaker. So let's do that. Okay, yeah. Then I am going to stir it well. So this sugar particles must get dissolved completely. Let's check it. Yeah, then I think the water, this sugar particles are almost completely dissolved. Yeah, you can see this. Yeah, is it interesting that the level of water is unchanged? It's remained the same. It is exactly 150 ml. There is no rise in the level of water even if I had put a spoonful of salt into it. In our basic concept, we know that sugar need, when we pour that sugar into water, it need to rise, right? The level need to rise, but it is the same. So do you understand the fact? What will be the reason behind that? Actually, what we did, what was that experiment? Yeah, we had some water and we checked the level of water. Okay, so we poured a spoonful of sugar into this water. Okay, so in our basic concept, we may feel that when on putting that sugar, the level of water may rise. But we could see that the level remained unchanged when this all of particle dissolved in it. Okay, so what might have happened over there? Why there is no change in the level of water? What is the reason for that? Yeah, you need to understand, in this water, as it is a liquid substance, the particles, the molecules are having some space in between them. They will not be closely packed. So there will be space already. So when these sugar particles dissolved in this water, that molecules will get into the space which was already there. So as a result of that, there will not be any rise in the level of water, because there was space and all these sugar particles are getting into the available space which was already there. Okay, so from this experiment, actually what we are trying to understand is that there is space in between the molecules, especially if it is liquid and gas. There will be so much of space in between them. Okay, so from this experiment, that's what we are trying to understand. You can try it home. Those who haven't tried it, kindly do this. You put some more amount of salt or any other sugar or something, and you just try this experiment. Okay, yeah, I hope you will do that. Then how was the experiment? Was it interesting for you? This kind of experiments, you will do so many different experiments in this coming chapters and your coming classes. So actually these experiments are making the science subjects more and more interesting. So by practically doing it, we will know much more things about it, and it will be much more interesting for you. I know that. Then now actually we are going to understand some more things in detail about the properties of these molecules. So we will call it as the molecular study. What is it? The molecular study. That simply means we are trying to understand more about the properties of molecules in different states. We know that a substance can have different states, like it can be in a solid, liquid and a gas, and basically these states it can have. So what is the property of these molecules in different states? That's what we are going to learn in this molecular study. Okay, are you ready for that? Yeah, let's check it out. Firstly, we are going to check out the molecular study of solid. We will begin with the molecular study of solid. So whenever we are going to understand this molecular study, you need to consider an ice piece. Ice is the solid state of water, isn't it? So the chemical structure will be same, but it remain in another state that is solid. Then we are going to understand how the water molecules are in a kind of ice, how they are moving, what are their properties and what are they capable of. That's what we are going to check out in this part. That is the molecular study of solid. Then if it is an ice piece or a solid substance, do you have any idea how they will be, these molecules? What will be their properties? Yeah, I know that some of the properties that you can guess. That means, as it is a solid, it is obvious that the molecules will be close to each other. They will be tightly packed. Yeah, that's why they are in such a state. All the solid substances are having molecules which are very close to each other. Okay, and one thing is very obvious, in all these states, they will be very tiny particles, and all these particles are actually so rigid. Okay, so small, ball-like, rigid particles. In all these states, they will be so small. That is the one common thing that you can explain in all these states in molecular study. For all states, one thing you can explain easily is that they all are very tiny and rigid particles. Is that okay? That is the first one. Then let's move on to the second property. In a solid substance, yeah, in this animated small video you can see how these particles are in a solid. You can see these particles are actually very close to each other. That means their intermolecular spacing is it more or less? Yeah, you can easily understand the intermolecular spacing is it is very less. When they are very close to each other, then you can understand their intermolecular. See, these molecules are actually very close. As a result, their spacing is very less. So the intermolecular spacing is very less for solids. That is easy to understand. And just because of this reason, they are solids. They are in a state like solid just because of this property, that they are having very less intermolecular spacing. Is that okay for you? Can you follow that? Yeah, well, good. Now, from that you can understand one more thing. If this intermolecular spacing is very less, then from that you can understand another thing about another property. Can you tell me that? Yeah, think about that. Think from the properties of molecules. Spacing, and one more thing is there. What is that? Yeah, the force of attraction is there. Intermolecular force of attraction. Then can you just tell me about this force of attraction in this solid substance? Will it be more or less? Yeah, right? Yes, some of you are saying, I can hear that. Yeah, when they are closely packed, that simply means whenever two bodies are so close, then their attraction will be more. Yeah, that's it. Whenever they are closely packed like this, then their force of attraction is supposed to be much more. So solids are the substances, the state in which these particles are having higher amount of intermolecular force of attraction. Do you get it? Can you follow that? Well, good. So we have got 3 points actually. First thing was that they are tiny, they are very small, these particles, and they are rigid as well. Then the second thing is that the intermolecular spacing for these solids are very less. And third thing that you can connect with the second one, what is that? As a result of which the intermolecular force of attraction is high in solids. Actually, it is simple to understand. You need to imagine it. As you can see in this, you can understand. You need to imagine things like this so that you won't forget the facts. In a solid, the molecules are having very less intermolecular force of attraction, and as a result, their force of attraction is much more. Is that fine? Okay, well, then we are going to see some more properties, like what about the motion of these particles? Actually, are they capable of moving in it? What do you say? Yes, as they are closely packed, even if we are tightly sitting somewhere very close to each other, then we know that we are not at all, we may not be capable of moving as such, right? Yeah, we will be congested to some place somewhere, then we may not be able to move in a freely manner. So the things are like here, that these molecules are closely packed like this, they may not be capable of moving from one point to another. the molecule in this end may not be able to move to the other end easily because they are closely packed. But even then, they are free to do one thing. What is it? Yeah, I told you that these molecules are something that is very similar to you. So what you may do if you are in a classroom and you are tightly sitting in a bench, very tight, strength is much more. What you may do? Yeah, you will begin to irritate the other boy. You will try to move comfortably. Okay, so you will try to do something as you can. The same thing will be for these molecules. Even if they are tightly packed like this, they will try to move in that possible space. That means they will try to vibrate. That means they are trying to move actually, because they are having so much more energy with them. So they will try to vibrate like this. These molecules will begin to vibrate in their position, because they are not capable of moving from one position to another, but even then they will try to vibrate. So you can imagine how the molecules will be there in all these solids. Yeah, they will be sitting close to each other. They will be having higher amount of intermolecular force of attraction, and even then they will be vibrating, vigorously vibrating. So all these are the properties you need to know about the molecular properties, molecular study of solids. Let's sum up. What is it? The molecular study of molecules. What is it? First of all, they are very small in size. Second thing, the intermolecular spacing of this solid will be very less. Third one, what is it? Yeah, then the intermolecular force of attraction is much more high in the solids. And the fourth one, what is it? Yeah, the molecules are actually vibrating in solids. Is that okay? So from all these, one basic property that we can understand about a solid is that as their particles, these molecules are tightly packed and their attraction is much more, the particles are so rigid, then these solids will have definite shape and volume for them. Remember that. And it is much well known for you that all the solid substance will have definite shape and also they will have definite volume. Okay, so this is all about a solid substance. So let's move on. Now we are going to understand the molecular study of, what will be that? We were discussing the properties of solid state of water. What is it? It was ice. Then what will be the next stage? Next state, what will be that? Yeah, it is the liquid state. Liquid state. Okay, so we are going to understand the molecular study of liquids. So what is that? What is the liquid state of water? That's just water itself, right? Yeah. So we are going to understand the properties of these molecules in this state. In liquid state, also I told you one thing is very common to all these states in molecular study, that is the size of the particles are very less. So you can say it, the same thing is there in the molecular study of liquids, because they are having particles which are very small in size, and also they are ball-like rigid particles. Then what about the second part? Second thing. So in this picture, it's showing a kind of representation of particles in a liquid. So what you can understand from this? What about the spacing in the molecular space? Yeah, you can understand that the spacing is more on comparing with the solids. Yeah, the intermolecular spacing is more than that of solids. You can simply say like that. On comparing with the solids, these liquids are having more space in between them, and that's why they are in such a state. So if we have an ice piece with this, then the molecules may be sitting very tight to each other. On getting heat energy, sufficient energy, they will begin to move. They will increase the space, and then we can call this state as liquid. For water, it will be ice and it is turning into water. Is that okay? So the molecules are having much more space in between them. So what is the second point that we can mention? Yeah, fine. The liquid state. In liquid states, the molecules are having more intermolecular spacing that of solids. Is that okay? Then one thing you can understand, what about the force of attraction? Yeah, when the spacing is more, then the force of attraction will be weak in comparison to the solids. That is the third point that you can easily say. What is it? Yeah, if you can understand the things about a solid, then you can easily say the molecular properties of solids and then the gases. You will be able to easily explain all these. So if you understand the facts, okay, don't try to by heart all these things. You will definitely make mistakes if you try to by heart. You can see the molecules are having much more space in between them. Then we can understand if there is more space, then the attraction will be less. That is it. Think in such a way. When the molecules are having much more space, then the force of attraction between the molecules in liquid state is weak in comparison to solid. Okay, just compare. In comparison, you should say all these things. So we have got three. What is that? First one, they are small. Second one, they are having more space than that of solids. Then third one, the intermolecular spacing, intermolecular force of attraction is weak in comparison to solid. I know that you may get confused in saying all this. So on understanding the facts, you will be able to say these facts. Okay, yeah. You will be able to, you try to understand the facts. Okay, so like I said, the importance of this kind of online classes is that if you have any doubts in it, you can replay the sessions. Yeah, that is one of the great good advantage of all these kind of online sessions. Okay, that's it. Make use of that. Then what about the motion of these molecules in a liquid state? Are they capable of moving, or are they simply staying in their own position? What do you think? Yes, as they are having much more space in between, they will be able to move, isn't it? Yes, as they are having much more space, they will be moving from one place to another within the boundary. Remember, like in which vessel they are taken. So in that limited boundary, they will be moving around. So they are capable of moving. So you can sum up all these points and they will be having much more energy than the solid state, isn't it? So we can sum up the properties of molecules or the molecular model of liquid as that they are very small in size. The molecules are not rigid as in the solid. Then the second point, they will be having much more spacing than the solid. Third point, their intermolecular force of attraction is, yes, tell me. Yeah, their intermolecular force of attraction is weak in comparison to the solids. And the last one, what is it? Yeah, they are capable of moving from one place to another within the boundary. Okay, so these are the things. So we can understand one thing, as they are capable of moving, these particles are capable of moving, then do you think that will they have any definite shape? Will they have? Yeah, if the particles are capable of moving, the shape will change, right? They cannot have any definite shape. They will take the shape of the vessel in which they have taken. So we should say they will not have any definite shape. But even then they will have definite volume. That is obvious, they will have volume, but they will not have any definite shape. These are the important points about the molecular model of liquids. Then what's next? Yeah, we know that the third state of water will be vapor. That means the gaseous state. Let's see that. So the molecular model of gases. Molecular model of gases. So if you understand the facts in the previous two states like solids and liquids, then you will be able to explain easily the facts in gaseous state. First one, what is that? Yeah, like in the previous ones, they are very small in size. They are actually not that rigid as liquid or the solids. Okay, then the second one, what about the intermolecular spacing? Yeah, you can understand the gaseous state means if we consider the water vapor, they are actually freely move around. So what we can understand, their intermolecular spacing is very high or very large in comparison with the solids and liquids. Is that okay? Then think about the intermolecular force of attraction. What will be that? Yeah, if the spacing is much more, then obviously the intermolecular force of attraction will be very weak. It is connected in such a way, right? If the spacing is much more, then the intermolecular force of attraction will be very less on comparison with the liquids and solids. Okay, then last one, what was that? Usually we explain the last one as this capable of moving. Then we know that if we check out the state of this vapor, you might have observed this water vapor is capable of moving the space available. It is actually not restricted to any boundary. This water vapor or any other substance in the gaseous state can move around in the space that is available for them. Remember that. So on comparison with other two, these molecules are more capable of moving around. Okay, so fine, just sum up all this. You can easily explain the properties of molecules or the molecular model in gases. They are very small, they are not that rigid. Then the second point, they are having more intermolecular spacing than solids and liquids. They are having more space. That's why they are in this state of this gaseous state. Then the third one, as they are having more space, their intermolecular force of attraction is very weak than this on comparison with the solids and liquids. You see, yeah. Then what about the last one? The molecules are capable of moving in the space available for them. They are more capable than the solids and liquids. Okay, these are the main 4 points that we need to remember in the molecular model of gases. Is that okay? So you just expect questions from these portions like the molecular model of solid, liquid and gas. So you just check out your textbook. There is all the things are given in detail in your textbook. If it is Selena, usually in our school we usually use the Selena textbook, and the things will be there in detail. Kindly read the things given in your textbook, so you will get so many information. That is the main thing. Even if you are getting many different classes, don't forget to read your textbook. That will help you a lot. Okay, and one more thing I told you, you need to keep a kind of small big book with you, like a keyword book, and write short notes in it. Kind of short notes. I told you to have one book with you. Okay, that will help you a lot. So remember these things. Fine? Okay, wonderful, good. So this is the thing about this molecular model. That is one of the important portion in this chapter. Remember it. Then, by understanding all these things, we can understand one very important thing is that whenever there is change in the spacing, force of attraction, actually there is a kind of so many drastic changes in the state of different bodies. A body can different state as well, right? You know about it. So if it is a solid, like if it's an ice piece, on getting heat energy, what will happen? It will change into liquid, and if it get much more energy, it will turn into vapor. Okay, so it is all about the heat that is getting into it. Okay, so whenever there is a rise in temperature, or whenever it is provided with the heat energy, the molecules will get more energy and they will begin to increase their spacing, and all those things will happen, and as a result of which there will be some changes in the states as well. Once again, remember what I am telling is that the states of matter, such a thing is very much known for you, right? A body can have different states based on the increased energy level of the particles in it. So a substance can have different states. So what makes this to happen, like different states of a matter? Okay, so let's see that. So one thing that we need to remember, the facts that affect the states of a matter. You know that different states are there. Then what are the factors that affects the states? You can understand the states are different based on the properties like the intermolecular spacing, and the second thing, the intermolecular force of attraction, and also the kind of energy these molecules are having. These three are the basic things that affect the states of a matter. Remember, this is an important thing. You need to remember, actually, when the spacing is much more and the attraction is very less, then we can say that this is a gaseous state. Okay, and if you think if it is a solid state, we can understand it is a solid only by understanding the spacing and this attraction and all these things, isn't it? That's why we are understanding whether it is a solid or a gas, right? So these are the three things we need to consider in order to understand whether a body is in this, which state it is, right? So what are they? The intermolecular spacing we will consider. If the spacing is more, it may be gas, and if the intermolecular spacing is very less, they are very they are tight to each other, then we may consider it as solid, like that. Then the second thing is that we will consider the intermolecular force of attraction. We can understand if the attraction, based on the attraction, we can also understand. Then last one is that we need to consider the energy level. Okay, in different states, the energy of molecules will be different. So the last one is that the kinetic energy of the molecules. So these are the three things we will, based on which we will differentiate in between these different states. Do you get it? Are you getting it? So once again, can you tell me what are the things we need to consider for stating a body, whether it is solid, liquid or gas? What are they? Intermolecular spacing, intermolecular force of attraction, and the kinetic energy of the molecules. Okay, so how can we increase the energy of these molecules? If I ask you a question like that, how can we increase the energy of these molecules? We know that in the solid states they may be having less energy, right? And just because of that they are staying like that. Then if we want to increase the energy level of these molecules, what we should do? Yeah, we can provide more heat energy for that. Whenever these molecules are getting more and more heat energy, that means they are getting more energy. Okay, so they will begin to move apart. They will have more energy. They will increase their spacing, and as a result of which they will change into another state. Is that okay? So this is the method. If we take one ice piece from this, usually you will have so many ice pieces in the freezer. If we take one ice piece out and keep it in the room temperature, what may happen? Yeah, within few minutes it will turn into water. So if it is so, how it is happening? Yeah, whenever we are taking this ice piece from this freezer into room temperature, that ice will begin to absorb all the heat from the surrounding temperature where it is placed. We know that usually the room temperature will be around, depends on different places, there will be any kind of temperature in the atmosphere. So this ice piece can absorb all the heat energy from the surroundings. Okay, as a result of which the molecules in the ice piece will get sufficient energy, they will begin to move apart, they will increase the spacing, and they will change into another state, isn't it? Yeah, that is it. So any body can change into another state by absorbing heat, and one more thing, yeah, by rejecting heat. It can absorb or reject heat. That is it. When liquid is changing into ice, actually it is not absorbing, it will reject the heat. We will learn about these things in detail later. Okay, anyway, you remember, always there will be a change of state by absorbing heat or rejecting heat. Remember, okay, it can absorb as well as it can reject. Okay, just because of these reasons, different bodies are changing continuously into different states of matter. Okay, so now we are going to understand this term, that is change in state or change in phase. What is the change in state or change in phase? Let's see. Yeah, how can we define that? The change in one state to another. The change in one state to another by absorption or rejection of heat energy is called change in state or change in phase. It is a very simple definition, isn't it? And there lies one more point, and it is a bit complicated thing. Actually, you will, there is so much to be explained about this very simple fact that whenever there is a change in state of a body, like if a solid is changing into liquid or vice versa, all these things will be happening in a constant temperature. During the phase change or the change in state, the temperature will remain constant. Okay, so you know that whenever this ice is melting, what will be the constant temperature? Yeah, it will be happening at a constant temperature, that is 0 degrees Celsius. And if water is boiling, there will be a constant temperature. What is that? It will be 100 degrees Celsius throughout all the water vaporized. Okay, so remember that whenever there is a phase change or change in phase, there will be a constant temperature. Okay, and the reasons and all other facts you will learn only in 10th standard. Now if I explain all these, it may not be that easy for you. Okay, and no need as well. We will study all these things in our 10th. Okay, anyway you need to understand, whenever there is a change in state or change in phase, there will be a constant temperature. Okay, and we will call it as the melting point, boiling point, and like that. Okay, so we need to include this thing also in the definition, like the process of change from one state to another. We are going to study this definition. You need to study it now itself. The process of change from one state to another, either by absorption, yeah, or rejection at a constant temperature. See what are the things we explained in this definition. What is that? The process of change from one state to another. That you can understand. The process of change from one state to another. Yeah, how can we change one body into one form to another? Yeah, either by absorption or rejection of heat energy. Either by absorption or rejection of heat energy. One more thing to be mentioned here. Yeah, at a constant temperature is called as change in state or change in phase. So whenever you explain definitions in physics, I have already told you, never try to say these things in your own words. If you try to say it in your own words, you will definitely skip many of these keywords, and usually you are not going to get enough marks for your exams. Okay, so you need to stick on to the words which are explained in your textbook. Okay, yeah, fine. So what are the keywords here? You can write some of the things in your own words, but basically the main keywords must be there as given in your textbook. Okay, you are not supposed to change it into another words. Okay, that will affect your marks in your 10th standard. I will explain about all these things later. Okay, there are something to be noted. So, how can we say that? The process of change from one state to another. That is first thing. The process of change from one state to another. But second thing, either by absorption or rejection of heat energy at constant temperature is called as, what is that? Change in state of change. So here what you need to understand is that you should not change these words. Which are they? The process of change from one state to another. That is the first thing. Second one, either by absorption or rejection of heat energy at a constant temperature. These are the words that you should not change at all. You need to stick on these words. Okay, and connecting all these words, that is possible for you. You can easily define it by connecting all these things. Right? What are they? The process of change from one state to another. Say with me. The process of change from one state to another, either by absorption or rejection of heat energy at a constant temperature, is called change in state or change in phase. The thing is that if you forget to write any of these words, definitely you are going to miss your mark. That is the way in which these things are evaluated, especially for your board exams. Whenever you are getting a definition, you are not allowed to skip any of the keywords. I mean, if you skip the word at a constant temperature, yeah, you may miss some of the marks for that. Okay, so all the keywords are more important. You should not avoid any of these keywords. So try to say it once again. The process of change from one state to another, either by absorption or rejection of heat energy at a constant temperature, is called change in state or change in phase of a body. Is that okay for you? Yeah, fine. I hope you could understand all these things. Alright? Yeah, very good. So let's revise and understand what we learned in this classroom session. Firstly, we did an experiment to understand that there is space in between the molecules of a body. You remember that? Yeah, try to do it. Okay. Then, what was the next? Then we understood the basic things like the molecular model in different states, like the molecular model of solid, molecular model of liquid, and the molecular model of gases. Okay, and all the different properties. I guess you will just understand and read all the things given in your textbook. Okay, fine. And the last one, what was that? Yeah, we get to know that based on all these facts, a body can change from one state to another, and that is called as the change in state or change in phase. And the definition is very simple. What is that? Yeah, you remember that? The process of change from one state to another. Yeah, come on, everyone say that. Yeah, I can hear, come on. Yes, the process of change from one state to another, either by absorption or rejection of heat energy at a constant temperature. Never skip any of these words, okay? So that is called as, what is it? Change in state or change in phase. It is also called as phase change and all this. Okay, fine, good. I'm happy about this, that I hope that you understood all these things very well. So we need to wind up this session. I expect that things are much easy for you, and if you have any suggestions you can comment here, and I expect some comments from you, like if you want any changes in the way of taking these classes, any kind of things to be improved, I expect your comments. Okay, and also share this classroom to your friends. Also subscribe this channel so that you will get notifications whenever I am uploading this channel for you, these lessons for you. Okay, so anyway, all of you be safe and happy. Okay, so see you in the next class. Okay, good day to you. Bye.